we're on. So, I don't know if you have something to talk about before we get on to.
No, not really. I'm just behind, so I'll pick up wherever you left off.
I don't think you're behind, really. We talked about completely unrelated things, which of course is fine. If you want to talk about completely unrelated things, I can just turn off YouTube and can discuss whatever. This is basically office hours for me. And I see we had a review of the pull request. I worked on it a little bit, and there's one thing I left for later for myself. So there's different repository, sorry. From the branch name I was on, it looks like I'm stealing the docs, right? So, standard review. I responded to most of it, and what's left is linking the thing we linked everywhere from floor division operators and things like that. So this says the numeric arguments are first converted to a common type, and this I did not pull to give it the branch to pull. Okay. So we linked this converting to a common type everywhere else. So we link it here as well. And that should be it, except there's this impl detail. We made that an admonition to make it more obvious where the implementation detail ends. But otherwise, this pull request should be good to go. And we can go to parenthesized expressions, which I think is something we started with. We started on enclosures, right? So this branch should have parenthesized groups, tuple displays, and that's it. So we should continue with tuple displays. And this continues with this group thing. So we have group, tuple, yield atom, and generator expression. I don't know if this is updated to the new grammar. Oh, probably not. This has both production list and grammar snippet, so I guess that's my convention. Whatever's grammar snippet is not updated yet. But let's check that. Let's see. The current docs on docs.python.org will have parent form. Let's display this display. Oh, so I guess it was converted partially. So the grammar hopefully has enclosure. Nope. Does it have atoms? It should have atom. Oh, here we go. So tuple, group, or generator expression, those are things in parentheses. So we have group documented. It's this one. Tuple comes first. I guess it needs to. Right. So what is tuple even? Oh, it's a parenthesized tuple. Interesting. Should probably make that a bit more obvious. So the grammar we're trying to document here is a tuple display, which is different from a tuple. So you can have numbers in parentheses, but what makes the tuple is not the parentheses, it's the comma. If you omit the parentheses, it's the same thing. It gets printed out in parentheses because of operator precedence. So it makes it more obvious that this is the tuple, and if you have like a tuple within a tuple, the wrapper of this thing needs to contain the parentheses. Wow. Otherwise, you know, this would not evaluate to the same thing as before, right? So that's the technical reason why we have parentheses when we print things out. But syntax-wise, the parentheses are there to group things. Or so I thought. There's a rule named tuple in the grammar, and it's parenthesized.
Oh.
What magic is this?
I know.
It's probably an optimization, as always. But okay, let's remove the things that aren't necessary here. So the type annotation for the syntax generator, the name of the variable that gets assigned in the parser, that's what's A and Z. Then there's this C code for the generation. We don't need that. There's more C code here, and we're left. Oh, there's one more name here, and we're left with parentheses, and then optional star named expression, comma, optional star named expressions. Right. So let's look in the grammar for star named expressions. So they are used in list, tuple, and set. Some invalid stuff. And the subject expression, so that's for the match statement. In their own definition, and that's it. That's it, yes. And star named expressions, I guess we can bring that over here. So star named expressions, if we remove all the stuff that is not necessary here. So this is the variable name and type annotation. So star named expressions are comma separated sequence of star named expression and an optional comma. So I wonder if we want to put it in here. So this looks a bit weird. Do you recall what this syntax means?
No.
So this means that this is a sequence of this star named expression thing separated by commas. Right? So usually what you'd have is something like this, which means you have one or more star named expression separated by commas and then an optional trailing comma. Or the whole thing could be optional, which means you can have 0 of them. You can just have empty parentheses. But in this case, it's a bit more complicated because you need to have a comma inside those parentheses. So this whole thing is optional. So one thing you can have is empty parentheses.
Oh.
Another thing you can have, so now let's remove this optional thing. Another thing you can have is star named expression with a comma at the end. And the other alternative is you have star named expression, comma, and then one or more star named expression. And an
But why is
optional
there a
trailing
dot
comma.
in front of star name?
Because this is the separator between these, between the individual expressions.
The dot?
The comma.
The comma. But then it says, but why does the second star name expression have a dot?
So this is, if we look at the introduction, this is the gather syntax. We have that here. Oh, we don't. We don't have the gather syntax.
Yeah, I don't remember.
Oh dear. Oh dear. Okay, I thought we had that. Which means the currently published docs are wrong. So if we look in the full grammar specification, so this says we have an extra complication, which is the cut, but we also have another extra complication, which is the gather. And I see we don't mention that here. Ooh dear, oh dear, oh dear. Okay, we need to fix that, I guess, as soon as possible. I think it's even in the 3.14 docs now, right? No gather to be found, but this only has cut. Oh, ha ha ha. Well, and this thing is definitely used inside here. So what do we do? Well, we need to add it, right? And we add it in the notation section, and we can use this wording here. So let's do that. Maybe at the end. So if you have s, which is something, which is like a syntax element, dot e plus, this will match one or more occurrences of e separated by s. The generated parse tree does not include the separator, which we don't really care. And we say this is identical to this. So it's identical to e followed by 0 or more occurrences of se, which basically means it's a bunch of e's separated by the s's. Does that make sense?
Okay.
So I guess we can unpack that.
I see.
We can unpack this whole thing, this gather, by saying this is star named expression followed by separator star named expression star. So let's plug that back in here. Right, so this means you can have 0 things.
Right.
If you have one thing, it needs to be followed by a comma. If you have more than one thing, you can have as many as you want. Right? And I
Nice.
see this is repeated here, and this says this should have 0 or more occurrences. So if it's repeated here before it, that means it should have 1 or more occurrence. And I guess this is a good way to document it. Like you could simplify this in a mathematical sense.
Yeah.
Into, you know, this can be left out. And this can be left out. Wait. No, let's me simplify the other way around. Okay, this is hard to simplify now. I guess this would be a comma or this, and the whole thing optional. But that doesn't make much sense. Okay. Now what is star named expression, and is it the same thing as this assignment expression? So let me go back to the tuple. The group used named expressions. Now we have star named expression. So let me build the docs and see where that links in our version of the docs. So this doesn't go anywhere. So this might be similar to assignment expression. No, it's not. So we need to... Oh, but the previous thing said start expression. So what's start expression? It can be star or just an expression, which is probably the same thing as our start expression, right? Something invalid.
I guess. Yeah.
Wait. Star named expression, sorry. Star named expression is either star bitwise or, which is exactly the same thing we saw here, just with a confusingly different name, or a named expression, which is which can be an assignment expression. So what's expressions say? So where star named expression? So named expression can be an assignment expression. Or an invalid, or an expression itself. Can you do something like a colon equals 1, comma, b colon equals 2. So that's an invalid syntax. Oh, but this isn't. So let's look at the currently published docs. How this works out. So parenthesized form includes star expression, and start expression here does not include assignment expressions. So the currently published docs are wrong. They wouldn't allow this. Which is exactly the thing we're here to fix, right? So we need to call this flexible expression, which includes assignment expressions and start expressions. So flexible expression is then the same thing as named expression here, right? Oh, the star named expression, sorry. So named expression can be an assignment or non-assignment expression, but star named expression can be either of those or a star bitwise or, which, as documented here, start expression is the start thing or the non-assignment expression. Flexible expression is those two things plus assignment expression. So flexible expression and the flexible expression in the old docs is the same thing as star name expression in the actual grammar. So we use the old name here for now. Does that make sense?
Yeah, that sounds fine.
It does. I'm surprised because this is just quite
No,
convoluted.
I mean, yeah.
Should we keep some kind of glossary saying what's the equivalent?
Yeah, maybe.
Term
I'm just putting a note
docs.
here that flexible expression is the star named expression is the new flexible expression.
Right. Yeah, maybe we should keep a wiki for this.
We could put a
Alright.
note in the. Do we have a glossary entry for star expressions or for flexible expressions?
No, I think it's just in the grammar.
Okay.
So, before parenthesized forms were one section, covering both tuple displays and parenthesized groups. But now I guess we need to be a bit more careful. So in parenthesized groups, which do not include tuples now, we should say know that empty parentheses that directly include a comma. I don't know how to best say that. So this is if the list contains at least one comma, which is pedantically wrong because well, there's expression list and it's not really a Python list, so this is not a very good term to use. Also, it needs to include that comma directly. And we can just say these are tuple displays, right? Or we can say, note that a parenthesized group must include a single expression. And expressions cannot end with a comma. Empty parentheses and oh, hello, how are you?
Well, good, thanks.
Or maybe we can say C tuple displays. Maybe we can say C tuple displays and generator expressions. generator expressions looks like it could be ampere. Gen expr, right. For other parenthesized syntax form or term we can use. Or we can say, note that not everything in parentheses is a group.
Oh, nice. Yeah. Not all who wander are lost.
Specifically parenthesized group must include exactly one expression. And cannot end with a comma. See Tuple Displays and generator expressions. For other uses of parentheses. Or for other parenthesized expressions. For other kinds of parenthesized expressions. Yeah, I think I like that. Okay. Or, well, the previous docs say parenthesized form. Maybe that's a good general term. Although I don't think it included the generator expressions. But maybe we can just use that. And without defining what parenthesized form is. Should be fine. Okay. Should say that empty parentheses denote an empty tuple, perhaps. Okay, well, I guess before I start writing this, I want to see how the tuples without parentheses are expressed in the grammar. Can we drill down to that? So if I have a bitwise OR, so that's composed of bitwise XOR, which has bitwise AND, which has bitwise XPER, which has shift XPER, which has sum, which has term, which has factors, which has powers, which has await primaries, which has primaries. which is primary.name or primary generator expression or primary arguments or primary slices or atom. Atom. Atom can be named true, false, none. Strings, numbers, stuff starting with parentheses. I don't see the comma anywhere. It's weird. You can have 1-2. How does that parse? Is that somewhere in the star named expression maze? Named expression. This expression. Is it hidden here? Valid stuff. There's disjunction and lambda. Disjunction has conjunctions, which has inversions, which has comparisons, which has bitwise ORs, and we're back where we started. Okay, I probably need to search the whole grammar for commas.
Oh God.
Global statement, non-local statement, assert statement. Okay, so those all have commas. Import from, import as, dotted as names. Per argument definition stuff. So star etc is in parameters. Params no default. With statement has some commas in it. Subject expressions. Open sequence patterns. But this is patterns, that's for match. Mapping patterns, items patterns. Okay, class patterns, keyword patterns. Type parameters. Expressions. Okay, expressions with an S at the end. That's easy to miss. That can have multiple things with a comma inside. Maybe that's it. And then we have star expressions, star named expressions. Slices have commas. Lambda parameters, which are unfortunately defined differently. And then we get to tuples, which require the parentheses. Start key, pairs, arguments, functions calls, keyword arguments, star arguments, star targets. Okay, delete targets, type expressions, and invalid stuff. Okay, so of that, only the expressions have the commas outside parentheses. And that's it. Oh, I see. Oh. So if the comma is not inside parentheses, it's the star expressions. So the simple statement includes star expressions. Ah, that's wild. Okay, so officially, this thing inside the parentheses is a tuple display, but this comma, this whole thing, that's not a tuple display. That's just a simple statement consisting of several expressions. And to me, who learned Python reading the documentation as it's written, that's a revelation. I guess it makes much more sense when you put it this way, but it's yeah, I need to adjust my worldview here.
So you're saying, hang on, so the comma inside I'm trying to figure out how best to summarize this. So a comma inside parentheses.
Yes, a comma inside parentheses is a tuple display. Let's call it tuple display.
Okay.
I think that's a new term we're coining this pull request, but let's call it that. And comma outside parentheses is just expressions.
Okay.
Which means the rule for expressions yeah, the rule for expressions needs to have this logic to create a tuple if there's a comma directly inside it. And I guess the same for star expressions. Yeah, it has the same logic there. It kind of sucks, honestly. That will lead to a bit of duplication in the docs. I don't know how much you can see it, but you know, this says that if you have expressions, which is basically the simple statement, kind of expression and then one or more expressions after a comma, so this needs to include this comma, then an optional comma at the end, that will create a tuple. If you have an expression followed by a comma, that will create a tuple. But if you have just an expression, that will not create a tuple. Right, so syntactically, this is just comma separated expressions with an optional comma at the end. But you need to have all three cases here to encode the fact that if you only have one expression that is not followed by a comma, it's not a tuple.
I see.
Well,
that's inside parentheses.
no, this is not inside parentheses.
Oh,
But
okay.
the same logic is for the Tuple display.
Okay, I see. Okay.
Oh, well, this doesn't. This is not the same logic, right? This is not the same logic because this always gives you a tuple, but it's used in this tuple and group, and this has the weird logic that excludes the single expression without a trailing comma. Okay. Huh. So I wonder, because so this is the original text. Let's look at the currently published docs. And the currently published docs say tuples are not formed by the parentheses, but rather by the use of the comma. Which is funny, right? Where, I mean, this doesn't say that. This, you know, this says how tuples are formed, and it says tuples are not formed by the parentheses, but by the comma. And I guess this needs to be explained somewhere in like simple statements. How do the current docs? Does this have expression statements? So that's the first thing. Expression statements. So here we have start expression. The start expression. Haha. Start expression is just a single expression. So you'd have to have start expression list for the commas. Okay. Do we have start expression list referenced anywhere here? No. Start expression list is used as some kind of yield list. Okay, so it looks like the currently documented formal grammar will also disallow this. Ah, ha, ha, that's fun. Okay, so so what do we say here? So okay. How do we word this? So we spent some time on atoms, on like names and numbers and strings. Now we get to here. How do we start this? Probably just by definition, right? So a tuple display is a comma separated it's a parenthesized comma separated list of expressions with an optional trailing comma. Tuple display must must include at least one comma. Or I guess it might be better explained by first saying what it does and then having the three cases separately.
Okay.
A tuple display is an parenthesized expression that evaluates to tuple object. There are three kinds of tuple displays. Two or more two or more comma separated values. I guess that's the most common form because
Yeah.
one element or zero element tuples are weird, right?
Yeah.
So
I
let's
think
just not say three kinds. If I say the most common form is, that implies there are more forms, right? So I can just get rid of that sentence.
Yes.
Hooray. Two or more comma separated expressions, or in the most common form, the parentheses contain two or more comma separated expressions. Nice and easy. So 1 2 1 2, right? 1 2 E. Give you 1 2 3. I don't know. Maybe we can have a Monty Python example later or something.
Yeah, exactly.
The
Cool. Yeah, that's similar to what we do with lists.
Oh, definitely. Right, so that's the first case. And now we should say what happens when you evaluate this, right? Probably. Kind of obvious, but we're writing reference documentation, right?
Right.
Or it's also possible. A Tuple display may also contain a single expression. In this case, the trailing comma is mandatory. Without it, you get a parenthesized group. By the way, in my personal project, I deviate from Pepe to here and I put a space after the comma, which Pepe explicitly disallows. But I think it's more obvious that there is a comma here if the spacing looks so weird. But for an official documentation, I stick to this. I think you can't put a comma inside here. And I guess we should say we can use colon here, and we can say make this a code block and say that trailing comma is not allowed in this case. Right? That's weird. Why is it not allowed? You can't write this. Which kind of makes sense, but it's another exception to the syntax, right?
Oh, because it's no.
No, it's just because it's
empty.
not here, right? Well, okay, so you can either use the comma as a separator of the expressions, or you can use it as a terminator of the expressions, right?
Right. Okay.
And if you look at it that way, you can't put a comma here because there's no expression to separate and there's no expression to terminate.
Okay, that I see. Yes.
Parenthesized list of expressions parenthesized list of either right there.
By a comma.
I wonder if we could do the grammar that way. So 0 or more expressions each followed by a comma would be this. But then 2 or more comma separated expressions would be this.
what was the Python grammar alternate grammar snipper?
So the group is like the context, like the grammar of which this is a part. So when I link, for example, to a piece of Python grammar, it'll go. I need to say that it's for Python grammar if I'm not inside it already. And I cannot define tuple twice in the same grammar.
I
So
see.
this is just to say, you know, it's not part of the Python grammar, but make it look the same. I just want to see how this looks. This is
sure.
maybe this is enough, and I don't need to put it in the grammar. Undefined label tuple display. What? Oh, too many columns. Thank you. Restructured text. Critical, unexpected section title. Oh. Parenthesized groups.
It's probably an indent somewhere. Or a character turn.
Oh no. It's here. There should be a comment.
Yeah, it's a comment.
I hope so. It's probably not meant parsed as a comment. Weird. So I think we have all of this.
Yeah.
Except for this thing and the index entries. So index, so we need parenthesized form and tuple display. Probably want parenthesized form up here. And this thing in here. Empty tuple. Oh, and the tuple display goes up here. Parentheses? Well, that might be for the parenthesized groups.
Oh.
Ah, this is nice.
Yeah. That is not, yeah. We should keep that.
Yes. But it's not just the empty tuples. You can have non-empty tuples.
Oh, that's true.
Do the same thing.
Since tuples.
You shouldn't compare them with is because you'll always get bug because it's not guaranteed by the language, but you do get true.
Do you want to just take out the empty tuple part?
Two occurrences of tuples with the same content. And I need to use the same terminology as here.
Okay.
I need to use the same terminology as in my other pull request. It's not merged yet.
Right.
So how did we explain it here? Was it here? Oh yes, yes.
Identity state?
Yeah, here. Multiple evaluations of literals with the same values, the same value, maybe the same object or an object with the same value. So same value is probably
Oh, okay.
the
Yeah.
term to use, and we should link this literals and object identity. Let me put in a to-do. So we use same value here, and then I think later here, for the purposes of this section, two strings have the same quote, same value, end quote. So yeah, so this is the term we want to use. Let's just make it plural.
Oh, I see. So you want to change that part back there.
Now I want to
talk about the value.
link same values.
Yeah.
But I don't have anywhere to link it just yet. So let's see. To do is unknown directive type, of course. Is 3 dots okay for you? Structured text? Yeah.
No, 3 dots? I don't think so.
Yeah, that's fine. That's not syntax.
Okay.
Parentheses denote the empty tuples. Yeah. Contain at least one comma. Commas, you get a parenthesized group. But yeah, I already said that here, so I don't need to put things yet another way. Good. Okay, but I guess I need to retain this part. Note that tuples are not formed by the parentheses, but rather by the use of the comma. The exception is the empty tuple, for which parentheses are required. Allowing and parenthesize nothing in expressions would cause ambiguities and allow common typos to pass uncaught. Well, allowing tuples without parentheses also allows common typos to get uncaught, but let's ignore that. Let's not criticize Python while we're documenting it.
Well,
Let's not put the criticism in the documentation, right?
Oh, right. Okay. Yeah. Oh, you put that to do in there. Did you want?
Well, I need to link. I need to merge this first before I can link it.
Oh, I see.
So that needs to stay for now. I think I only need one of these because this is just harder to follow. I mean, this is just a flex saying that I can encode
The
this.
first one is better, no?
The first one is better, definitely. Yeah. So this says, note that the tuples are not formed by the parentheses. Which you can view two ways. Either conceptually, no, to make a tuple, you use the comma, not the parentheses, which is correct. Or you can view it from the point of view of the syntax. Say, and it would say basically that tuple displays don't require parentheses, they just use the comma, which is incorrect because tuple displays are now defined as needing parentheses around them. So what you should probably note that several maybe we can use this form thing. Without parentheses.
So the parentheses do not create the tuple. They're just there for display. Is that right?
Well, the tuple is formed by parsing a tuple display. So a tuple display is the syntactic thing that when you evaluate it, it always creates a tuple. Right? There are other syntactic things that also evaluate to tuples and look similar. They look exactly the same, but they don't include the parentheses. Right?
Oh, okay, I see.
Those are not tuple displays. Wait, by definition, they're not tuple displays, and tuple displays is a term I'm defining right now, so this is a kind of a weird thing to say, but I'm defining tuple display to just mean this. Right, that's a new term I'm adding to the documentation. I don't think that was there before. Let me check. Nope. Not there. Not there. Yeah, so I'm adding a term to the documentation, which of course is a heavy thing to do, sort of. But the overarching goal of this entire effort is to bring the documentation closer to the grammar, and the grammar has something called tuple, right? I can't call it just tuple. That would be confusing, so I'm calling it a tuple display because this list thing is called a list display, and this set thing is called a set display. So this tuple I'm calling a tuple display, and that always has the parentheses in it, right? So I will reword this to say that while tuple displays always require parentheses, there are other ways to create tuples which look similar but they don't require parentheses. Does that make sense?
Yes.
That's the plan here. So I know that tuple displays are not the only way
To form a tuple.
to form a tuple. Parsing Python syntax now forming a tuple without parentheses. Only with a comma separated list of expressions. The most prominent example is the expression statement. So you can have 1, 2, 3, logma, no parentheses. I guess you do. You can have return 1, 2, 3.
Because if you haven't, I see now. So because if you have something within parentheses and there is no comma, it's not a tuple.
Right. Yeah.
Okay.
This is not a good term. Maybe in several places, Python syntax forming a tuple without parentheses.
Yeah, in several situations or conditions, circumstances. Oh, places. No, that's right, because it's syntax. Yeah, it's perfect. Yeah. Yes. Oh.
And now,
Oh, I didn't realize that. Oh, that's okay.
yeah, it's fun. You can return a comma-separated list of values, and then you can also unpack it.
Oh.
So it's symmetrical in that way. But what I need to do now, since I'm at the end of the section, I'll probably make this a pull request. I need to look if the documentation for the return statement and the expression statement in the current docs actually corresponds to this properly. So where would that be? That would be simple statements, there's expression statement, and the returning statement. So expression statements, nope. You can have a start expression there, and a start expression does not allow multiple things. So we need to change expression statement to our good friend flexible thingy. Let's see what the actual grammar has to say. So simple STMT. Just assignment and star expressions. And assignment must precede expression, else parsing a simple assignment will throw syntax error. Right, so the actual grammar has two kinds of expression statements. We have assignment which is a single assignment, so you can have a colon equals something. No, it's not colon equals, so it's a equals something. Or you can have so assignment. So that's assignment, and then we have star expressions. And star expressions single star expression or the tuple forming stuff. Do we need to correct the docs we're linking to? Let's see. Return statement has an expression list. Aha! Nice, and that has expressions. If I define a function, put a return in it saying a colon equals 1, 2, 3, that's an invalid syntax, so this is good. So the return statement has an expression list which does not include assignment expressions. So this one is good.
Oh.
Return statement is probably the example I
Okay.
should use here then. That's the one that's documented correctly. Oh, you can have LST plus equals 1, 2. Oh, here you don't have. You don't need parentheses around here as well. Should give an example.
Okay. Oh. Oh wow.
I don't know how useful
Okay.
that is. Wow.
Yeah.
So this fun variable is now 3, and I multiply it by 1, 2, 3. That's valid. Isn't Python fun?
It is.
Yeah. There's no way to type that correctly with mypy.
Oh really?
Oh, I guess you could use any
Oh.
the intersection
sure,
between
but that's not-
integers and tuples. So yeah, there is a way to type it correctly, but it's just as convoluted as the syntax itself. Okay, this is probably not a good example to put in the documentation, but let's look at more of these. So yeah, augmented assignments, returns, and those are the only thing that have the expression lists. And yeah, I guess you cannot use these, you have to parenthesize them. I think I want to put a long term to do here.
Sure. That sounds like a good idea.
So let's say the most prominent example is the return statement.
Yeah.
Another prominent example is the expression statement, but as of this writing, its docs imply that you need parentheses. I wonder if I should actually commit this into the documentation itself. Because on one hand, we should keep to-dos in issues, not in the code. On the other hand, this does answer the question, why didn't we put that example here?
Should we put in like a little note or a warning that
maybe we'll put in a note.
And then say, this raises an issue, this raises the following issue, which, is is under discussion or under consideration.
Yeah. So, well, this is the same issue as this one. This is where the expression chapter of the docs, but it continues after this one. And I guess this should have sub-issues like the lexical analysis. Let me add sub-issues here. So we have this one. And expressions.
Oh, cool. Yeah.
Now I can get rid of this. Well, this is the plan. I guess I can't create just a note here. Okay, that's sub issues then. Let me double check that this is actually correct. So expression statement, then we have assert assignment. Assignment needs the equals. Augmented assignment, which needs the augmented operator. Annotated assignment, which needs the colon. Pass, del, return, yield, raise, break, continue, import, future, global, non-local, type. Those all need the keywords. So yeah, expression statement is the only thing that deals with expressions. It only includes one start expression, not the flexible expression. It's a bit gnarly to untangle this right now. I don't think I can just replace start expression with flexible expression, because then that allows assignment expression Oh, flexible. With the expression list. Because why not? Can I do this? Ooh. Yeah, then expression. I cannot. Yeah. So if I used expression list, that would only have expressions, and apparently star stuff is not expressions. This is fun. How does this work in the current star expressions? Oh yeah, this has star expressions, which includes star expression. Yeah, it's a bit fiddly to get the details right now. Right, so I don't want to just make the change right now. I need to put in this. Well, basically it's a to-do, but let's make it a note. Now it's a bit jarring that we have a single example and then we have a plural here. So should we add another example? Well, the only other example we have is augmented operators, which are just weird.
I don't remember what augmented operators are.
The plus equals and star equals.
Oh, you mean when you overload something?
No, when you it's the combined operator and assignment, like plus equals.
Oh, those. Oh, I see. Okay, yeah.
But I don't think I can come up with a sane example that uses these for tuples.
Well, wouldn't the example you had earlier with the plus, where you started with the empty tuple and then you
I needed to start with the empty list, because if I started with an empty tuple, this, like, the behavior is even. Oh, the behavior is fine here.
Yeah. Okay.
So, I mean, this is not a good example. It's just so weird. You can technically do this, but while, return without parentheses is fine, if you want to do this, I would at least put it in the parentheses. I don't know. Yeah, I don't think this is a good example. This is like a curiosity, and I try to only keep the curiosities to the stream, to not smuggle them into the doc.
Sure, no, that's,
unless it's like a
right,
security, security concern, right?
Yeah.
Some of these, like the details of the Unicode stuff, can be abused, but this, no. This is just weird.
Yeah, fair enough.
Oh, I'm sure it can be abused, but I don't see a way how. I guess I don't have a better example, or a different example. So I'll keep it like this. And should this be like an admonition, a note?
Yeah, a note.
Note's a kind of admonition. Okay. What are we doing? So we say that that there are enclosures. Enclosures can be groups of or tuples. Groups of assignment expression, and assignment expression does not include their commas, so that's fine. We have tuples. Well, so parenthesized groups, Tuple Displays. And these are what we will add in this pull request. A group is an expression enclosed in parentheses. Parenthesized group evaluates the same value as the expression inside. I guess I want parenthesized group to be the full term. And then I can just say group here. This is a usage note. I wonder if this is too many examples.
I mean, they can always get rid of examples.
I mean,
suppose.
That's a syntax reference. Do we assume that the reader knows what this weird operator is?
Sure.
If we assume it, then we can get rid of the plus and star.
Yeah. I mean, at the end of the day, if they don't understand the example, they can look. I mean, you know.
Well, yeah, it's hard to look. It's hard to look for this. I mean, if you search for this. Oops. Now our engine doesn't. That. I guess that's a bug. It's probably tracked somewhere too. It's probably an index entry. We might, when we go through these, add the operators themselves to the title of the section, right? But no,
yeah.
This just goes to expressions, not to shifting. Okay, that's a whole different issue. What I wanted to... What did I want to get to? Is this good enough?
I mean, it's certainly an improvement.
So I'm saying in the same way as in math notation, and this is not really math notation, it's programming language.
Oh.
Yeah,
I guess I could take that
I
out.
see that we're out of time though, so let me add this back and commit, push to my branch, and we'll continue next week. Thanks for your attention.
Right on. Thank you.
And
that's great.